All right, cool. You guys ready? Recursion? Yeah? All right. Everyone's looking at their computers like it has the answers. Let's hope it does. Let's go ahead and read out the objectives. Can I get someone to read out the first objective? Define recursion. Seems pretty straightforward. Cool. How about number 2?
Name the 2 parts of a recursion function.
Nice. Cool. How about the last one?
Solve problems using.
This is pretty reasonable, right? It's like define it, do it, that's it. So recursion on its own, I would say, in 4 or 5 months, it would be like, this is a simple concept. But right now, it might feel kind of heavy. And usually it's just because it can be kind of complex to wrap your mind around, but it's really pretty simple at the end of the day. Simple doesn't always mean easy, though. So let's take a minute, because you did the reading last night. Go ahead and in your tables define what is recursion. Come up with some definition of what it is. 1 to 2 sentence definition. That is your own definition, not from Wikipedia. Great, go. Got a minute. All right, 20 more seconds. If you guys are good on the first question, you can move on to the second one. All right, I'm gonna go ahead and call on someone. Tell me about this. Oh, it's Brandon with an E. Brandon, you're not here. It's your fault. All right. Oh, Brandon with an O. Wow. All right, define recursion. What's recursion?
It's like when you call upon a function within a function.
Call upon a function within a function. You can do that though with any functions.
The same function.
Yeah, right. Call the same function inside of itself. Is there anything more to it? That's it.
Also, like manipulating, I guess, the iterative, or I would say the iterative, a certain number, so that it reaches a base.
Sure. So in terms of how to get to work, right, we need those 2 parts. But if we're trying to figure out if a function's recursive or not, you really just look at the name of the function and look inside. Yes, no. Right? So concept-wise, actually pretty small. But yes, let's talk about them. What are those 2 parts of recursive function? Greg?
2 parts, the base case and recursive case.
Yeah, cool. You or anyone else? What does that mean?
The base case is kind of where you want it to end its recursion, and the recursive case is how it keeps calling itself.
Yeah, right? So we have this one side that's keep going, and in the other case we need something that says now you can stop. We're thinking about a regular for loop. Just regular old for loop. If we had to use the term base case for that, how do we apply that to a for loop? What's the base case for a for loop? The initialization would set it up, right? So that'd be the first part. What would stop it?
The middle part. So
Yeah.
I equals 0, and then I is bigger, let's say, some B.
Something, right? Yeah, that middle part, that conditional. That's when that for loop ends. All right, so it's actually not a super new concept. You guys have worked with it before. We're just giving it some fancier words, right? More money, that's how you make that good money, right? So in this case, we're saying that base case is just the part at which we're done. If that part's messed up, and again, think about a for loop. If I type that in wrong, if instead of saying I is less than array.length, I say I is, I don't know, while it's greater than or something like that, what's going to happen?
We just keep going.
it just keeps rolling, right? It just keeps on going. Exactly the same idea with the recursive function. We're just rewiring up, we're just changing around how it looks. So good hard and fast rule is anything you can do iteratively, you can do recursively, and vice versa. Essentially, or rather like in terms of getting the work done, there's not a difference. Either way, you can still loop through stuff. So let's go ahead and look at an example. I just want you guys to diagram what is happening. Swap over here. All right, can you guys see this all right? Cool, so I'll give you guys a minute or so. Go ahead and just take a look at this function. I want you guys to define what's happening, make sure you understand how it's working, what you expect to happen, and then just answer the question, what do you think would happen if we moved line 9, that's this one with the console log, below line 10? So if we swapped these two things, how would that change the output? Cool, talk about it. It's got about a minute.
If you know why it is that, it really explain why to you. You know what I mean? So looping through array takes this array of 3 elements. If it's going to express them, if it's undefined, the CDA, we're going to define it ourselves as an 0. I think it's good. And then to block that element, the index is less than the size of the array.
Yeah, you put
So
console
we're going to recall it in summary as a square root. That's what so the first time through, the reason so on 13 I'm not passing it. So the conditional on line 7 is triggered. I on 0. We will console log array I to say I array, and then the conditional on n is true is 0 plus 2. So we will call the function.
That's what happens because unless you write the label, the higher the involved in the index is
So now on line 7, index is called 0, 2 equals 1, then 1 is going to pass the 0.
Skips over that.
So that's going to fail. It's going to log in array index 1, just be, and then the conditional on line 10 is going to pass again. We're going to go into the function the third time, and this time we're going to pass in index 2. Index 2 skips the conditional on 7, it prints out on line 9.
All right, another 30 seconds or so.
So then, right now we're in the inverse function, that one finishes, which finishes the second number, which finishes the first and then so yeah, that's it.
So it doesn't matter where you
It's kind of like how you try to draw it out here, it's like going in. So right inside the function you log as a function, log function all the way until you reach that. So the log was function.
Yeah.
And then you can move inside out. So we go back.
So the first time through, we call loop through array index 0 on line 10. When that condition passes, and then we go loop through array, and then index 1.
All right, let's go ahead and
First one's still
talk about it.
finished, and then we
What's difficult about understanding what's happening here? If anything. I feel like it is pretty difficult. It's weird. It's weird to think about. So what is challenging about this? Nothing.
You have multiple functions. Well, you have the same function running multiple times.
Yeah. Yeah.
Like what actually went first.
Yeah. right? It can feel sort of like, I think we can look at it and be like, cool, recursive. Might even be able to reason about like, well, based on the name and what I can kind of expect to happen, I can figure out what the output might be. But having to step through line by line, trying to figure out like, well, wait, when does this happen and why does this thing happen before this? Maybe more just concretely, like when is this function done? Right? This is the interesting thing about recursive functions, that they're not done until they hit the base case. Right? So trying to actually reason about like when does this finish can be sort of hard to keep in our head, particularly as these things get more complex. Cool. All right, what do you guys think the output's going to be?
A, B, C.
Cool. And if we swap it, we swap lines 9 and 10. It's gonna have CBA. I know. It's kind of a big difference. Yeah? We move 2 lines around, and the output is exactly the reverse. It's kind of interesting. So diagrams out. There are actually a number of ways we can diagram out recursion. The main way, though, is that we can talk about a call stack. What was a call stack again? We talked about it eons ago. Something.
First in, last out.
Last in, first out. Okay, what?
Execution order.
Cool. Awesome. Right? So we're talking about when things are going to happen. Right? Or in some way, we're talking about stack, right? It's keeping track of things and actually deciding when certain things run. So when we invoke this function loop through array on line 13, let's walk through it. We get another little frame on the stack here. Loop through array, say LTA. This is the first invocation of it. So we step through on line 7, I is not defined. Right? Another way we could write this using a E is 6, if you guys like that better. Let's just do that. Is that better? I feel like that's better. Oh, so nice. Who need to write that whole if? Oh, God, so boring. All right, cool. So much better. So we walk in, right? I is not defined, so we set I equal to 0. Great. Seems chill. Then we log that out. We log out the element at 0, so we log out A. And then if I is less than the array.length, -1, we continue going. So is I less than the array.length, -1? Yeah, right? So is this function done? It's not, right? I know there's just one thing left for it to do. It's like, oh, but it's almost done. But computers don't think about almost, right? It's just black or white. So it's not done yet. So before it can finish, the next invocation must happen, right? And then next invocation, notice we're passing in I this time. We're passing it in +1. So I is going to be 1. Now we're going to log out B in here. And once again, we're going to continue on, right? Because that condition is still met. So finally, we get to this last case. I is 2, we log out C. At this point, are we going to run what's in the if statement? I is 2 less than the array.length -1? It's not, right? It's equal to it. So at that point, the function is done. What's a little weird about this one is that there's not an obvious base case, but the base case here is that nothing else happens, right? So that means this invocation is done, so it gets popped off the stack. This invocation is done, so it gets popped off. This invocation is done, so it gets popped off. Right, so it just walks its way back down. When we flip the order of those two things, instead we build our way all the way up. And only when we bypass that iterative step is when we start logging, right? So that's why we see it starts to log its way backwards. Any questions about that? Does that seem pretty reasonable? Cool. Cool. Let's take a look at another example. Let's see. All right, let's take a look at this one. So describe how this function works, same thing. Identify the recursive case and the base case. What would be a good name for this function based on some topics we've previously discussed. Cool. Spend a minute or so, talk through what's going to happen, why it's going to happen.
So first of all, so is it so recursive like that what's the first thing it's going to call? And the call, what's the callback? It's the log. It's the log. So the first thing it's going to do is it's going to like
All right, another minute. I'm going to ask you guys to explain it to me.
so like what's the first thing recursive is basically it's within the operator. It's essentially
It's actually not. It's like exactly when it comes up here, right?
what's it going to say? The first number is the first value, right? That's what it's not. But what the call is it's just saying it's being the first color of the array. Callback. And then as the callback. So as we move through it, it's going to log its color. No, the callback is all red and green. And that also be the first value of that array because you're using the so like the color is and this where this color. So it's like and what do we say? And eventually that's going to get smaller and smaller, right? Because you're kind of so it's the color and it's red and it's on constant first. And then it's that also what's the rest of it? Yeah, it's that new array. That we're going to call and that's going to go through that process. But what's it going to say to the first? Yeah. What parts that you're looking at tabs? No, because we were no, because that's not the rest. So what is it? What's the new story?
All right, let's talk about it. It's like the structuring. It's so nice with recursive functions in particular. Right, let's actually go line by line. There's a lot going on here. So line 7, see that? What is happening? Talk to us about that function signature.
So inside the function, we pass into a parameter. One is an array, and the other one is a call.
Sure. Yeah. And what happens with that array?
So the array split the first item of the array, and then we have the rest.
Yeah. Right. So first, there's two parameters coming in. There's two parameters, two arguments coming in. First one should be an array. We're going to split that apart into two variables. First, the first element, rest puts everything else into another array. So the first time through, the variable first will be red, and rest will be green and blue. And the callback is going to be some function. That can be whatever you want. Sweet. On line 8, what is happening? Dylan.
So it's saying that if there's no value in the first index of the array, then return.
Yeah, why?
So that's when you get to the very end of the array and the rest of things anymore.
Great, so we get to the very end, so we need some way to basically say, oh, there's something else. That's all. Nothing else in here. Cool. For line 10, oh, it's not unusual. Sadly. Alright, neat. What's happening on line 10?
You were invoking the callback, which just passed in on line 7 is the logger function.
Yeah, right? So in this case, all we're doing is just saying, invoke that function, do the thing. All right, our last line. Matthew, what's happening on line 11?
The array for the rest, which is the array, and logger on 15. So just do those things.
Yep, and so what does that mean for, if we hit this point, right? Here was our base case. So what's happening down here?
That's when it's going to print what's in, or the print the column.
So that's actually happening on line 10, right?
Oh.
So the callback is the thing that's actually invoking it. Right here, for recall recursive function, that's this function up here. Right, so this is how we move along to the next step. Right, is that we actually just, with the rest of them, in the first case will be green and blue, just move along with now a smaller array. Right, we're sort of decrementing the size of the array by 1. We need to pass in logger so it retains that callback. Any questions about this?
So if you put the callback first under recursive fn, would it go green, blue, green, red, or?
Let's try it. Let's do it. All right, so node, well, let's just run it as is. Cool. We got red, green, blue. Now let's try and swap those things. It's very neat, right? Just need to swap those around, and suddenly the order of these things happening totally changes. Cool, cool, cool. What would be a good name for this function? What do you guys think?
RGB.
So this takes a callback and an array. It doesn't have to be colors, right? We have a generic utility function here that runs a callback on each item for each. I mean, it's like pulling teeth. So it's for each, right? It's just a for each function. We don't have index or the collection in here, but essentially just running for each on each element. Do you believe me? Yeah. Cool, Wes. Thanks for putting together the example. It's pretty rad. Oh, wow. Okay, all right, let's do the next one. So real quick, here's the same function we just looked at. Here's another way to write that same function. Those will both work. Do you guys like one better than the other? Same thing. We'll do the same stuff. It's either better to understand, easier, do not care.
I like the front one.
Why so?
I feel like it's succinct. You don't have as many curly brackets.
Right. Yeah, not in quarterbacks. That makes it kind of nice. Cool. What makes it succinct? It's actually the same. I guess just one less line of code. But
I mean, you're just, because you're not having curly brackets, you just put the return in one line.
sure. Okay. Cool. Cool. Any other thoughts?
I kind of like having the obvious blocks. It's just,
Do you mean here?
yeah.
Like just it's a little bit more clear. Like that's what's happening. That's it. Cool.
At a glance, that's just right there.
Sure. Yeah. Yeah. Any other thoughts?
I like the second one because I can see the base case.
Cool. So the second one's a little bit easier to see the base case. Here there is a base case, right? What is it?
First exists.
If it first exists, though, we keep going, right? This would end up being the recursive case. So in this case, we were talking about the base case for this first function, right? We'd say when that doesn't run, it just returns undefined, because that's what functions do. There's no return statement. Right, so we skip over that, it ends up being the base case. So I would agree, I think the second option is a little bit more clear recursively. I also agree, I think like the first one kind of maybe looks nicer in some ways, a little bit more clear. Up to you all, as long as you can identify both those points. Cool. All right, last example we're going to work through. I'm not even asking you which one it is. This is map. It's map. It runs map. How does this run map? Give you guys a minute to work through how is this working. And finally, diagram out how this final array gets constructed. And what I mean by that is go ahead and draw with persistent next to you, one of these call stacks.
So I guess stack in the bottom. Sorry. So does it work top to bottom?
Works bottom up. So the first execution goes to the bottom. Then you build up.
First thing that so with the example of 0 to
Yeah.
0 states your actions. In that case, will it be the first element log at the bottom, or is the first function that's inserted?
The first function is in basically a console log if you wanted to add it to the stack. Or you can just add it.
Is that separate from the function being?
Any function or function that adds it to the stack. I think if something that basically runs and is finished, you would typically add it and then it's over.
So in that case, we would still have the first function instead of first third, it's just printing it out to do something else.
It still builds it up that way, it's just when it actually logs.
Two equals 32. I'm still confused about it, but I didn't get. I'm still a little confused. Just with so you can call that. Yes. The order of log names and what's supposed to be. Like I think this should be concatenated first. So I'm not sure why. So what's it's not so like this like how do you like this is supposed to be first should this be first?
The hours in it's like so the same location. So that's where you start.
Is that actually
It will keep it in the exact same order actually.
I'm also a little confused by your the biggest block is the function is slightly above.
Sure.
This block.
So your longest any function call, right? You could add something as, but if it finishes,
I don't think that's
it
partial.
just goes back.
It's within.
So in this case, the thing to think about is by the time we get to the end, where is everything? Right. And once we hit to that base case, there's a workforce order of all those different applications. Right. So we're calling like cemetery.concat. Public first map is going to turn into another one of those return statements. Right. The next map is going to turn into another one of those return statements. So in that case, we end up with them all hitting. Okay. Yeah. Okay. No. Okay. You just try and look at the figuring out where things are.
Oh,
And I try to expand it.
I feel like you could separate this first to be more so you're concatenating first value and then
The value would be 24, right?
function again. So it's kind of like inside itself there. But you want to concatenate with that first value in the array.
So I think so you're right. Except I would just add like it won't actually concat anything yet, right? You're right. This would be 24.
So it's all that.
This function isn't going to finish running until this is done. Right.
So-
That's I think the tricky part about this is that you're right. We get this value 24 here, but then we have to wait till this finishes before this entire step actually happens. Like this. Right. So the next time through, it's going to be slightly smaller until we get to that last point. That's the part where it's going to start to concat everything. So that until like that is finished, it's not going to concat.
So just like they'll create a new value 28 and it's create a new and that will like this is a smaller array
Still not quoting.
the sum of the second array and that will
the last step is that we're going to hit this base case, right? So finally at that point that we're going to actually start adding stuff together.
That's what we're doing.
That's going to be
Okay, so
Be the first.
push that here. And to the C.
Each time you return an integer that you with value all that and whatever the rest of the okay, yeah. So
And then you're,
yeah, so the return is always an array. It's added with
so don't forget the return is a value, of the function.
All right, another 30 seconds or so, and we'll talk it over.
Yeah, just wrap my head up. Wrap my head up this last time. That's the issue.
All right, y'all ready to talk about it? So, all right, so what I would love to do is have one of you all help me draw out this call stack. So, Wendy, help me out. What's the first thing that's going to happen?
First thing that's gonna happen is it's a map. The first thing it's gonna return first. First thing first will return it's a map of the first value.
Map the first value. So values coming in are going to be 12, 14, 16. So what's first going to be the first time through? Maybe I can change this name so that I don't have to keep saying first. Let's say element. So there's no element, return an empty array. So the first time through, what's element going to be?
The
So the whole array is going to be this entire thing, right? So we're using destructuring there.
is 12.
Yeah, so it's going to be the first element, right? So in this case, element, the first invocation of this is going to be 12. What's rest going to be?
14 and 16.
Yeah, right, an array of 14 and 16. Cool. Is there an element? This is a truthy value.
It is a true value.
Yeah, right? So we can skip over that first part. And so talk to me about this last line here, number 8. It's where everything is happening. What is going on?
So into the array, and then you concatenate the element. It's a callback. So it looks like a callback function of which is doubler.
Yeah.
So it's 12 times 2,
Cool.
and then moves that into the empty array, and then goes back into the function again of map to figure out what the rest, and then use the rest of the, which is 14 and 16, and go back to callback, which is another doubler.
Cool, cool, cool. So in terms of what gets returned at this point, though, at this moment, nothing gets returned, right? Until map is finished.
Yeah.
You're right, though. Eventually,
But
they'll
move
concatenate.
something inside that empty array.
It actually doesn't yet.
Doesn't it?
So here's the weird and cool part about this one, is that this function invocation, concat's function invocation, doesn't finish until map is finished.
So where does the value live? Just somewhere.
It's just getting held on in this part of the stack, in this particular frame. right? So if let me separate this out. I think you'll see stuff that just looks like this, but we can make this slightly easier to understand by saying the const value. It's the same idea, right? We're just giving this thing a name. So in this case, right, value is stored in here. It's going to be 24. And then before we can finish concatenating, we actually have to run map again. So we add another frame to our stack. Inside of here, what's element going to be? Second time through. 14, right? That means rest is just going to be an array with 16 in it, and our value is going to be 28. Then we're going to call map again. At this point, element is going to be 16. Rest is going to be an empty array. Value is going to be 32. Then we call map again. At this point, what is element? Nothing, right? It's undefined. So finally, we actually hit return. We actually return that array. This value comes back down to the next part of the stack. So now we have an empty array, and that's what's getting concatenated on this previous thing, right? So we end up with, let's start from the back, I have this .concat. Somewhere over here, return back this empty array. Then we return back 32. Right? That part's finally done. Then we get 28. Then we get 24. So the full statement ends up looking essentially like this, but we had to iteratively work our way through to get there. Another way to look at this, instead of, if this helps, great. I think this is like the canonical way to describe this. Another way to look at this is that recursively, this thing has to go all the way to the bottom before it can return all the way back. So you might look at that as like this sort of step kind of thing. So we start to invoke the first function, but we hit this part where we have to hit this recursive step. So we move down. We hit another recursive step. Move down. Hit another recursive step. Finally, we're at the base case. Now we have all the values sort of waiting in the wings, right? And that's where we can actually start to work our way back up and consolidate all these things together, right? So in this sense, we're actually working our way all the way down, getting all the values, all part of their individual little frames, right? Each one has its own little scope, and we're working our way back up to accumulate that thing together. Questions about this? Questions about this one? Nah? Like if I give you some problems, you can do this? We'll see. All right. We'll see what happens. Any questions on how this invocation, though, is working? All right. Cool. I think we already actually did something pretty similar to this, so it is all good. All right, so here's the plan. And for the rest of the time, that's all of it. That's the whole recursion thing. Loop over stuff, build a base case. Best way to work through this, though, is to actually try some stuff out. So what I would love for you guys to do is two different things. First of all, why don't we practice the stuff that we've been talking about the past few days. Go ahead and create a new NPM project. Someone will play some music for us. What's that? What sound was? Nothing. All right. Create a new NPM project. Install Mokuchai in Istanbul/NYC. Let's create tests for the following problems, and then we'll solve each using recursion. So this is exercise 1. So the problems you're going to solve is some function that adds the total length of all strings in an array. So I have an array, a bunch of strings, and it's going to give me the sum total of all those things. We're going to write a function that finds the longest string in an array. So it actually sifts through. This would be kind of like the find function, right? And finally removes all strings above a given length from an array. Any questions on what to do there? Cool. All right, the last thing would just be after that, there's this recurse words. Recurse words. You guys get it? Thanks, Brandon. Okay. You guys can try that. Those have some challenging problems inside there as well.
What was a joke about recursion?
Is it? Have you searched recursion?
Yeah, so recursion. It took me a second to realize what was happening. I thought that up.
What do you mean recursion? What do you mean recursion? What do you mean? Is that it?
Yeah.
Nice.
So,
Nice.
it's not very good.
You guys get it? It's a developer joke. It's pretty funny. All right, you're ignoring me now. So go ahead and keep working. I will be around, and we will touch base before noon. Cool. Have fun. Good luck. Feel free to work together.